Bright Duty. Every student matters.
Hello dear students, my name is Amit Ajmani and today we'll be taking up under motion chapter of 9th class physics, we'll be taking up about the details of equations of motion. Fine. Now there are three equations of motions, students, and it is not like I have written this is first and this is second and this is third. They are actually known as this is the first equation of motion, this is called the second equation of motion, and this is known as the third equation of motion. We cannot interchange. We can't say that writing this particular thing first as this is the first equation. No. The first equation of motion says that V is equal to U plus AT. I repeat, V is equal to U plus AT, where V is the final velocity that we have already studied till now. We should be knowing it. U is the initial velocity, A is the acceleration, and T is the time, right? This is the first equation of motion. The second equation of motion states that S is equal to ut plus half at square. I repeat, S is equal to ut plus half at square. The third equation of motion says that V square is equal to U square plus 2AS. I repeat, V square is equal to U square plus 2AS. Now, looking at all these three equations of motion, all the alphabetical representation that we have used here, what do they stand for? Let us see. As we have seen, U is the initial velocity, V is the final velocity, A is the acceleration, and S is the distance travelled, and T is the time taken. T is the time taken, right? Now, along with these, we also must know their SI units. The velocity, whether it is initial or final, they are represented or expressed in meter per second. Acceleration is expressed in meter per second square. Distance travelled is measured in meters, and time taken is expressed in seconds. And all these alphabets that we have used in these three equations of motion, they are all small alphabets. While writing, some students tend to make this mistake. They write either capital V or they write capital T or capital S. They are not used like this. They are always in small alphabets. So, these are the three equations of motion that you need to remember. I repeat, all these three. V is equal to U plus AT is the first equation of motion. S is equal to UT plus half AT square is the second equation of motion. V square is equal to U square plus 2AS is the third equation of motion, right? Now, from where do these equations come from? In most of the schools, the derivation of these equations of motion, that is not being told, and in some schools it is being told. It is being taught as to from where these equations of motions are derived. We will do the derivations, of course, in order to get the detailed concept. Rather than just blindly following and learning these equations, we need to know exactly where from we have derived them. Even though in many schools they are non-evaluative, but still we need to know, just because we need to know the concepts, right? First of all, while deriving, we will derive the first equation of motion, right? So, we will see the derivation. First equation of motion says V is equal to U plus AT. Now, to derive, we need to remind ourselves of a few steps, right? If we learn these derivations step by step, then in that case it will be quite helpful to understand and to learn them, right? So, in order to derive the first equation of motion, we will start up with our formula, that is, we know that acceleration is change in velocity upon time taken, right? Now, change in velocity, when I talk about change in velocity, I say that change in velocity means final velocity minus initial velocity. We have already done this thing while we have studied the topic acceleration. Still we repeat it again. Change in velocity means final velocity minus initial velocity divided by time taken. So this will be our formula for acceleration. Now if I represent all these in their alphabetical representation, acceleration is expressed as small a. Final velocity we know we represent it by small v, minus initial velocity is represented by small u, and time taken is represented by small t. So a is equal to v minus u upon t, right. If I cross multiply it, I will get a into t is equal to v minus u. Taking this minus u on the other end, I will see v is equal to u plus at, and this is what exactly my first equation of motion was. Quite simple, isn't it? So to conclude, we say that v is equal to u plus at, where v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time taken. So when you are asked to derive, after putting up these, we need to write all the expressions where v is what, u is what, a is what, and t is what. Got it? Fine. So this is how we have got our first equation of motion. Clear, students? Now let us see about the second equation of motion. Let us talk about the second equation of motion, which said that now second equation of motion says that S is equal to ut plus half a t square. This is what we need to derive. Fine. To start with, first of all, I'll take up step number 1. We will start the derivation from this formula that we know that what is average velocity. We have studied that average velocity is equal to initial velocity plus final velocity divided by 2, that is the average mean of both the velocities, or I can also represent it as u plus v divided by 2. This is my average velocity. Let us name it as equation number 1. We will use it later, okay. So this is the first step. We will start our derivation with this particular formula of average velocity, which says that it is initial velocity plus final velocity divided by 2. Alright. Now I will take up step number 2. I know that speed is equal to distance upon time, right. So from this formula, by cross multiplying, I will get distance will be equal to speed multiplied by time. Why I have taken this formula? Because in second equation of motion, this is what exactly we need to correlate. S represents distance, right. So we need to know what distance is equal to. Fine. Now I know that speed and velocity are same except the direction. Speed and velocity we have differentiated, both are same with same SI units. The difference is speed is a scalar quantity having only magnitude, whereas velocity is a vector quantity having magnitude as well as direction. So if we are traveling about in a straight road, then speed and velocity are equivalent. So I can replace speed with velocity, right. And if I am not given the initial and the final velocity separately, I will just take what? Average velocity. So now I can conclude or I can express my formula as distance is equal to average velocity multiplied by time taken. Got it? Now, the average velocity as per equation number 1 have been expressed as u plus v upon 2. So, replacing the value of average velocity in this formula, I can write, instead of writing average velocity, I can write u plus v by 2 multiply by time. I am expressing it as small t. Clear? These are basically the two steps that we need to remember. Now, I need to remember every time what exactly I am going to derive. The actual formula is S is equal to ut plus half at square. Now, here I have got S is equal to u plus v divided by 2 multiply by t. In this formula, I see that there is no v. Fine. In this formula, we still have got v. So, that means I should remove v. And how I am going to remove v? Very simple. V is equal to u plus at. This is as per the first equation of motion that we have just derived above. Right? So, if I replace v with u plus at, what I will get is S is equal to u, I am writing as it is, and rather than writing v, I am writing u plus at divided by 2 multiply by t, and in bracket I need to specify where from this particular thing has arrived, because v is equal to u plus at as per first equation of motion. Now students, all your hard work and effort, that is the end of it. It's just like simple calculation now that is required. Let us see how. This equation becomes u plus u becomes 2u plus at divided by 2 multiply by t. Opening up the bracket, because this is a plus sign, so this t is going to be multiplied with both the things. I will get 2u multiplied by t gets 2ut plus at multiplied by t will give me at square divided by 2. Got it? This is what I conclude. So, if I separate these values, I can also write it like 2ut by 2 plus at square by 2. Right? This is also expressed like this. Now, I will cancel out 2 with 2 and I am left with S is equal to ut plus half at square. This divided by 2 I have written as half. This is exactly my second equation of motion. Clear students? So, for deriving the second equation of motion, we need to recall what we have done. Just 4 steps, 4 things we need to do. Firstly, we need to start up with average velocity, which is equal to initial velocity plus final velocity divided by 2. Keeping this thing as equation number 1, the second step is speed is equal to distance upon time. So, distance is equal to speed into time, and speed and velocity are same, and since initial and final velocity are not specified separately, I will take it to be average velocity. That is the main step. Now, distance is expressed as average velocity multiplied by time. Third step is putting the value of average velocity from equation number 1 here, and I will get this setup. Distance is equal to u plus v by 2 multiplied by t. The fourth and the important thing I need to do is I need to replace v. Why? Because the derivation that I am doing, the formula that I am deriving doesn't contain v or final velocity. So, from first equation of motion, we can replace v with u plus at. That's it. That was the fourth important step. Next, you just have to do the calculations and will derive our requisite derivation, second equation of motion. Of course, after deriving it, we will specify where we need to relate, where s is the distance travelled, u is the initial velocity, t is the time taken, and A is the acceleration, right? So whatever alphabets we are using in this formula, we need to specify what do they represent. Got it? This is our derivation of second equation of motion. Clear to all? Good. Now coming back to the third equation of motion. Let us see what exactly was the third equation of motion, and let us see how we are going to derive the third equation of motion. Third equation of motion said that V square is equal to U square plus 2AS. Right? This is what we are supposed to derive. Once again, we need to remember the various steps which we need to take. Step number 1, we will start up with second equation of motion. We know that S is equal to ut plus half at square. Now students, whenever we write, we know that in this we are not including the examiner, right? I know it that S is equal to ut plus half at square, but the examiner doesn't know it. So wherever necessary, we need to specify as to from where do we come to know this, that S is equal to ut plus half at square. So we need to specify second equation of motion, because now nobody can deny that second equation of motion is not this. So to start up, we will say that S is equal to ut plus half at square. Right? Now students, quite importantly, just a little bit of observation part. In this formula that we are supposed to derive, do you see any t time? No. So in this formula, the second step that I need to take is I need to remove t. Right? If I remove t, that will be all. Just calculations will be required. Now what should I write instead of t? Once again, we will take the help of first equation of motion, which said that V is equal to u plus at, or it can be written as at is equal to V minus u, or t is equal to V minus u upon a. So from first equation of motion, I get to know that t can also be represented as V minus u upon a. Now I will just put the value of t over here in this equation, second equation of motion. That's it. Let us see. Now this equation becomes S, I will write as it is, u I will write as it is. Instead of writing t, I am writing V minus u upon a, right, plus half into a into t square. Now this t is square, so very importantly, I am just writing, instead of writing t, I am writing V minus u upon a, and since it is square, so one thing you need to remember is it will be whole square, right? Simply opening up the brackets, what I will get is t is equal to uv minus u square, this u I have multiplied with both, divided by a, plus half into a v minus u square upon a square. I can write like this, upper bracket separately and lower bracket separately, right. So a I have done square part, 1a will be cancelled out with this. So now my equation, it is just simple calculation, you just need to do the calculation, it is quite easy. uv minus u square upon a becomes plus, in the numerator I am left with v minus u whole square, divided by 2 into 1a is still left, so I will write 2a. Got it? Fine. Now there were two options actually. First was I do not open up this bracket, and if this bracket remains there, then we can see that v minus u can be taken as common. Or second option is that what I do is the way I have been doing, uv minus u square upon a plus, now v minus u whole square, we know this identity that a minus b whole square is equal to a square plus b square minus 2ab. This is mathematical identity. Using this, what I can write is v minus u whole square will become v square plus u square minus 2uv divided by 2a as it is. Again, next step, a and 2a, I will take an LCM which will become 2a. Multiplying this part with 2, I will get 2uv minus 2u square plus v square plus u square minus 2uv will be as it is. From here I can see this is plus 2uv, this is minus 2uv, they'll get cancelled out. S is equal to, again I see here is minus 2u square and plus u square. This I can write as minus u square plus as it is v square divided by 2a. Now, by cross multiplying, I will see that this equation becomes 2as is equal to minus u square plus v square. Taking u square on the opposite side, I will get v square is equal to u square plus 2as. Now, this is what actually I needed to derive. This is our third equation of motion, v square is equal to u square plus 2as. Of course, we will be specifying where v is the final velocity, u is the initial velocity, a is the acceleration and s is the distance travelled. Clear to all? So, this is the derivation of third equation of motion. Just 2 steps. That is what we need to remember, just 2 steps. First step, from where to start? We will be starting up with the second equation of motion, that is s is equal to ut plus half at square. Second step, I will just replace t with v minus u upon a, and from where did I get it? I get it from first equation of motion. By replacing the value of t, this is the second step. After that, it is all the calculation that we have done which will lead us to our final answer, that is the third equation of motion, v square is equal to u square plus 2as. Got it? So, this is our third equation of motion. So, students, now I hope you must have understood as to from where these 3 equations of motions come. Now, important thing, I repeat again, that in most of the schools this is non-evaluative, but I prefer that you need to understand rather than just merely ratifying it. We just don't want to apply something which we don't know, right? So, these are the 3 equations of motion and we will be using these equations of motion